Hello and welcome. Today I'm going to be adding an electric element to a brew kettle. I just recently for Christmas got this new 10-gallon stainless steel kettle. I'm downsizing a little bit from my larger one so I can carry things around a little easier. And I want to turn this into an electric kettle, so I'm going to add an element. Now, I bought all the parts and pieces I need to do this, and I'm going to show you what they are, and then I'm going to walk you through what I do to add the element to the kettle. Well, if you'll notice, this kettle already has a couple welded fittings for the valve and for my temperature sensor, but it doesn't have a fitting for the heating element. Well, I've got two heating elements here, and I'm going to use this one that's out of the package. It's a 240 volt, 5500 watt heating element, and this is a Camco model 2932 Lime Life element, which is very good as far as resisting dry fires. If you accidentally leave it on for a few seconds without any water around it, these things will handle that for a time, unlike other elements which will blow up quicker than shit. Anyhow, this is the one I'm going to add. My other element, which is still in the package here, is a 4500 watt 240 volt element. It would work just fine. At 200 volts it would easily boil the water in this kettle, but I'm going to go ahead and stick the bigger element in it. If at some point I want to swap them out, that's what I'll do. Now, for this particular installation, I went to Brew Hardware and picked up one of their element, what do they call it? It's a hot pod element housing. What this is a piece that sticks on the side of the kettle and allows me to encase the wiring and take it apart relatively easy should I ever need to mess with the wiring. In order to install this, I'm going to need to drill a hole in the side of my kettle. Now, I'm going to open this up a little bit. It comes apart into two pieces, and this piece right here is going to go onto the side of the kettle, and it's going to hold the element in the kettle. Well, a nut's going to hold the element into the kettle, but this is going to sit here so I can screw the housing onto it and protect the wires again. What it came with, and I ordered, they have two different ways you can order it. You can order it with or without the 1 1/4 inch nut you need to hold the element in place. I ordered it with, and it also came, I don't know if you can see it, but there's a silicone O-ring and some crimp-on fittings that are circular holes that will go onto the screws on the back of the element. Now again, this is an 1 1/4 inch threaded element, and the nut is an 1 1/4 inch stainless steel element. Now this one on one side of it has a groove for that O-ring that'll hold it in place. Now the key to get this thing working is to get a seal that's not going to leak. Now you have to be pretty precise in the hole that you drill in the side of your kettle so that it's not too big and allows water to leak out or wort to leak out, as it were. To do that, there are a couple ways. Actually, there are 3 or 4 ways you can put this hole in. I have step drills here that I could, this big one on let's see, your left or my right, goes all the way up to 1 3/8 by about 1/4 inch steps, and it definitely has an 1 1/4 inch step on it. I also could use what are known as knockout punches. Now what a knockout punch is a 2-piece device. One piece has teeth on it, the other piece is a collar, and it comes with this big finely threaded bolt that what you do is you put the teeth part on one side of the metal, the collar part on the other side of the metal, and through a pre-drilled hole the size of this, you pull the tooth side, you screw this nut in, and it eventually pulls that tooth side all the way through the collar and punches a hole in the side. Now, that works really well, and it's really good to use one of these if you have 3/4 inch holes that you need for standard 1/2 inch threaded fittings, like for a valve or for a sensor. But this particular hole punch is slightly larger than I want it to be. Now, these punches are made for conduit, and as such they're made for 1¼ inch conduit. This particular one is, but the hole that it drills is actually closer to 1 3/8 inches than 1¼ inch. So that extra 1/8 of an inch or an extra 1/16 of an inch on each side is a little bit too much play, and I don't know that I want to do that. I have used this thing on other holes that I put elements in, but it does make making them leak free kind of tricky. The last option that I have is a hole saw, and it's just a pretty standard hole saw. It's 1¼ inch. It's got teeth on it, and basically just drill the hole through it with the hole saw. Now, I'm not sure of the quality of this particular hole saw. I'm going to try it, and if it doesn't work, I'm going to end up using the step drill. But I'm going to try this first because I think it's going to work, and it is the right size. So, without any further ado, let's get started. Okay, now looking at the side view of my kettle here, what I'm going to do is, here's my handle, and I'm going to put the hole centered right underneath the handle in the side here. Now, I don't want the hole to be too high because I want to be able to put a false bottom of some sort on top of the element to keep the bags that I use for brewing a bag from touching it. So what I have done is I've measured the collar thing, and this is 2 inches across. Actually, it's a hair over 2 inches, and I'll show it to you here. It's just a hair over 2 inches, which means I need 1 inch on either side of the hole, the center of the hole, for space for the collar so it doesn't sit too low. Now, I'm going to go to the side here, and I'm actually going to come up about 1.5 inches to 2 inches, maybe 1 3/4 inches from the bottom. And that will leave plenty of room underneath the element for the water to circulate and boil. All right, the first thing I'm going to do is I'm going to measure the distance between the handle pieces, and that looks like from end to end it's 4 inches. So I'm going to mark a mark 2 inches across that handle, and I'm going to measure down, and I'm going to mark a spot here about 2 inches off the bottom, or a little less. Okay, so I've centered that hole there, and I've made a mark about 2 inches off the bottom, or 1 3/4 inches off the bottom. Now what I'm going to do is use my square here and come straight down from the mark on the top. And it's a little trickier than I'd hoped. I'm going to go from the top. That's a little too wide. This is definitely not rocket science, so this is not a real big deal to get this absolutely perfect, but okay. Now it looks like my mark is I'm trying to rest this on the bottom so it's level. And okay. So if you can see, I made a line there, and I don't know, there might be a lot of glare in the picture, but right there is where I want to center my hole. Now that I've got it marked, the first thing I'm going to do is take a punch and punch a hole, well, not punch a hole, mark a spot so that my drill doesn't wander. Now again, I've got an 1¼ inch bit on the front of this, and just for the sake of seeing it, I don't know if you can see, it's just the perfect width. Now this is an old element that burned out that I've been using as a gauge for me, and it's going to be a perfect fit. So here we go. I'm going to see if this drill's any good. Okay, before I drill, I am going to spray a little WD-40 on that to give me a little bit of lubrication. See if I can maybe. Okay, well, I tried the hole saw, and the hole saw drill wouldn't even make a mark on the metal. So what I'm going to do is I'm going to use a step bit and see if I can get a hole started. It started, but it's not doing very well. So what I think I'm going to do is use a better drill bit to at least punch a hole. All right, that worked. Now with that hole punch, I'm going to see if this hole saw bit will do any good. Well, it's making a mark. Not doing much other than that. Yeah, it looks like it's loose. Yeah, that's barely making a dent. So what I think I'm going to do is try the step bit. Now I got a big one here. Now step bits are kind of weird. Sometimes they work well, sometimes they don't. Hopefully this works now that I got this hole drilled. Okay, as you can see, it is working. Now one thing I didn't notice, didn't show you, is I need to go to the second from the bottom right here. It says 1¼ inch. And what I'm going to do before I get that far, I'm going to check it and test it. And one thing I'm going to do now, though, is I'm going to run it from the inside to deburr it a little bit. Down to, let's see, that one I just hit was 7/8. Now I kind of wish I had a good punch that was the exact size, because that really makes a nice clean hole. But like I said, I don't. Once I get this done though, I'll clean up the burrs that are going to inevitably be in the inside, and then I will hammer it smooth so it'll be flat and it'll be good. I'm still at it. I put another battery in my drill. Okay, at the point now where I'm going to be testing it every step to make sure that it's good. I still got a ways to go. All right, another plan. My hand drill wasn't doing very good, so what I'm doing is I brought this over to my drill press, and I'm going to drill it here and see how it works. Now I'm going to have to go pretty slow, or this will have the same problem. It's working, it's just going super slow. All right, after about 25-30 minutes of drilling, here's my sample fitting. Here it goes in. Going from the other direction, you can see there's not a whole lot of slack there. Now what I'm going to do now is I'm going to take a hammer and flatten the hole out, and clean it up real good with a grinder and something. I don't know, we'll see, but we'll come back. Well, that took a while. It took me a good hour to use the step drill and drill a hole up to 1 1/4 inches and get it all cleaned up and deburred and flattened out. Really, seriously, it took at least an hour to get that done. So it would have taken me a fourth that time had I had the proper knockout punch of the right size for the hole. So if you're going to do this, I'd highly recommend either getting a good 1 1/4 inch hole saw or get a knockout punch, and really the knockout punch is the way to go. You can pick them up, I imagine, for somewhere in the neighborhood of 20 or 30 bucks online for the 1 1/4 inch one. The set I have of 4 conduit punches really only cost me about 20 bucks, and I've used it a lot for holes in all kinds of kettles, but I don't think I'll ever do the step drill again, if I ever have to. Anyway, the next step in the process is getting this in here. Now, I'm going right angle. And one thing I had to do is make sure I get that fitted in there and not tear up the Teflon tape when I'm doing it, because it is a fairly tight fit. So, first thing I'm going to do is wrap it in Teflon tape. And let's see. Oh, this is kind of backwards. Okay, I need to go with the threads. So, and I'm kind of doing this ass backwards. And I'm going to do 4 good times around. That's probably overkill. And I know I'll probably have to wrap it around once or twice inside the hole. But you always want to wrap with the threads so that when you put the nut on, the nut tightens down your Teflon tape and doesn't unroll it. Okay, now the instructions say to put the element through the collar and then insert it in here. Like I said, I'm going to be real careful because I don't want to mess up the Teflon tape when I'm putting this in. And I think I did a pretty good job there. In fact, I think I did a real good job. Now, in the kit that I bought, in addition to the ferrules that'll go in the end of the thing, it came with an O-ring. And, excuse me for a second, the O-ring goes around the inside of the fitting, and I got some plumber's grease, or tag lube. This is plumber's grease. As far as I'm concerned, the same thing. I'm going to put this around there so that it goes on the fitting well. And, you know, just for the hell of it, I am going to put another thread of tape on here. Okay, now I'm going to slide the O-ring over the threads. Roll it on. So, let's see if we can get close up there. There's the O-ring. Sorry about that. And next, I'm going to slide the nut over everything and screw it down. Now make sure the O-ring, that the nut is facing the right direction with the indented part of the O-ring, and screw that mother in. Okay, now I'm going to hand tighten it in the outside here. Now that I've got the nut inside, it's a matter of tightening it down so that that O-ring snugs up against the side of the kettle. Now, I have a pair of good sized pliers for the inside, and I've got a water heater element wrench here. Now, the element wrench will go over this thing here and allows me to twist the nut, or twist the fitting, and I'm just going to hold the nut inside and then make it good and snug. I don't think I want to over tighten it. And now it's installed. The next step is to do a leak test, and that's really important. I don't want to hook up any of the wires and do anything more until I test this thing for leaks. So that's what I'm going to do now. So I'll fill it up with water, and if it doesn't leak, we'll be back in a minute here. Alright, I'm filling it up with water, and I don't see any of it coming out anywhere. Nothing leaking in the bottom. Now you'll notice that is off of the bottom, so I can set it on the countertop, and it's not leaking. That's actually about the easiest I've ever put a fitting on the outside. Just for the sake of demonstration, let me walk over to one of my other kettles here. This is what I did on one of my other kettles. That's just an outdoor electrical box, and I drilled a hole in the box and I drilled a hole in the kettle, and similar thing. I put the O-ring on the nut on the inside, and I'd show it to you, but right now I got some water heating in it, but you can see the nut down there in the corner. But this is my hot liquor tank. My other boil kettle, well, over there is a turkey fryer kettle. I did a similar thing. Now that's just a regular old electrical box. not an outdoor box, although I did seal it pretty good. My regular boil kettle is on the floor over here, and I don't know if you can see. It's set up very similar in the way I set up the hot liquor tank. Essentially, it's just a box protecting the cable and the cord. Now, the one drawback to the one that I'm working on now, this one, is that it does stick out quite a ways. You'll notice these others, like that one there, since it lays flat against the side of the kettle, the cord doesn't stick out very far. But anyway, whoa, I let this thing fill almost all the way to the top. I'm going to stop the water. And I'll let some of that out shortly. Although maybe I'll just leave it. No, I'm going to let some of that out so I can carry it and do a boil test here in a little bit. The next step in the process is hooking up the power cord. Now I've got a 12-foot long 10 gauge power cord here. On this end it's got L630 plug on it, an L630 plug which plugs into all my controllers, twist lock. And on this end I have gone ahead and prepared the wires, stripped them back so that I can crimp them. Again, they gave me some crimp-on connectors here, 2 power ones and 1 ground one. On the inside of the cover for the element, there is a bolt that goes through that's screwed to the outside and the inside, and it's got some threads that stick up, and then they gave me a little nut, you can't see it, that will ground everything. Anyway, so all I really need to do is put the wires on the crimp connectors and crimp them. Now, one thing, I really would much rather solder these than crimp them, so I'm going to probably do both. Right now I'm just going to crimp them, and I mean that will definitely hold it. It ain't going anywhere, but I may stick a bead of solder on there just for the hell of it. Okay. Well, I got the fittings put on the ends. So now what I'm going to do is I'm going to thread all my cables through the ferrule here. First thing I'm going to do is get the ground wire on. If nothing else, that'll hold this wire and the cable itself in place. And like I said, it goes on the inside of this to a nut. Well, it doesn't want to go easy. Ain't that always the case? Let's see if I'm going backwards this way. What we need is a pair of needle nose pliers, and that would probably make this a little easier. There you go. Okay, that's on. And thread this little nut on here. And that's going to be the hardest part because there's not a lot of room to move around in this thing. Alright, I got it. Alright, well, it's all ready to go here. Now, all I got to do is supposedly just push this thing in place, screw it in. Now, I haven't tightened up the hose thing yet, or the wire thing. Alright. Alright, that's pretty snug. Now just to make sure that's in, and now I just got to tighten up this nut on the end here. And, okay, we'll see if my crescent wrench gets big enough. Yeah, there it is. Now what this will do is just snug that cord in there, and it ain't going anyplace. Oops, sorry about that. Okay, well, you get the idea there. My tripod's messing up though. All right. Alright, that's about as tight as that's going to get. That thing's nice and snug. There you have it. I got to tell you, looks okay. Now I'm going to do a boil test. Sorry about the angle of the camera. All right, I've got the kettle plugged in. It's working fine. I'm actually calibrating my temperature sensor, which is this thing right here on the outside. And if you look, you can see I've got a temperature probe hanging into the water off the side there. And it's right by where the sensor sticks into the kettle. Now right now, my sensor says, or the probe says it's 152 degrees. And I just stirred the water up, so it should be right. But my controller says it's 155 degrees. What that tells me is that my temperature sensor in the kettle needs to be calibrated. So what I'm going to do is I'm going to try and get it so that the temperature up here matches the temperature on here. So I'm at 153. So this is 3 degrees hotter. Now I'm not sure what it's set at right now, the offset for the last thing that was in it. Right now it's at -1. So what I'm going to do is, I'm not really sure which way I need to go here, but I'm going to bump that up to 3. And we'll see if I went the right direction. Okay, 3 says it's 152.2. My thing says 153. That's pretty dang close. I'm going to go ahead and make that 1 degree different. And again, I think I go that direction. So what that does is it says that my temperature sensor... Oh, I went the wrong direction. No, maybe I didn't. Because I got 155 on my sensor and 154.8. That's pretty darn close. So I did go the right direction. So what that tells me is that the sensor in the kettle at 155 degrees reads 2 degrees lower. And I need to increase the temperature shown by 2 degrees. Now let's go ahead and verify that. Right now I got 156 and it's at 155.7. So I'm going to take that 2 degrees away and put it to 0. Now I'm thinking that I am adding 2 degrees to whatever the reading is. So I'm going to take away that 2 degrees so that I'm not adding, and this will be the default sensor. Okay, so it went up 2 degrees. So again, the temperature sensor is reading 2 degrees high, so I need to take 2 degrees off. And I need to tell it that it reads 2 degrees high. So the temperature sensor reads 2 degrees high. So compensate for that, which means essentially take 2 degrees away. And then I'm right back to 155. Okay, now I always calibrate my temperature sensors at 155. The reason I do that is because that's where I'm going to be mashing at, and that's where I want the most accuracy. You mash at anywhere between 149, 148, and 153 to 155. So I know if it's right at 155, that when I'm mashing, I'm going to have the correct temperature reading as I'm recirculating in my brew in a bag. So that's why I calibrate. So I know that the kettle is working. I know my element is working just fine. And just for the hell of it, I'm going to bump it up to boiling and make sure that I can boil with no problems. I don't have any reason to believe I can't. So what I'm going to do is I'm going to set this to be 220 or 250. That's good enough. So it's just going to continue. It's going to run 100% and it's going to start boiling. Again, I don't care if it's accurate at boiling. I don't care if it's accurate at freezing. I care that it's accurate right in the middle, in the sweet spot in my brewer's window for mashing. Boiling's boiling. I mean, if I'm going to boil for 90 minutes, the temperature on the sensor doesn't matter. I just want to make sure it's boiling. So anyway, that's what I got. All right, all done. Element's working just great. The housing looks good. It wasn't too difficult to put on. It was very time consuming. I will never use the step bit to drill a hole that big again. I think I'll go get me a bimetal hole saw or the actual 1 1/4 inch knockout punch that really works well and probably only takes 5 minutes to make the hole. I tell you, that's the only way to do it. Anyway, it works good. The hardest part, other than the hole, was getting the ground on the little post that stuck out of the side of the housing. Couldn't get my fingers in there to get the nut started. Had to loosen up the outside screws so that I could screw it a little bit onto the nut. Once I did that and pair of pliers, it was fine. If I had a ratchet and a small socket, it would have been fine too. Didn't want to go looking for them, so I just made do with what I had. Other than that, it's good. Another piece of advice, always calibrate your temperature sensors. I calibrate mine right in the brewer's window where I'm going to mash because that's where I want it most accurate. Right now, it's almost to boil, and it says it's at 205 degrees. I'll see where boiling is in just a few minutes here, and we'll see how accurate it really is. In my climate, I'm about 1,000 feet above sea level, so it usually boils at around 211 degrees, give or take a degree. But again, that really doesn't matter. Boiling's boiling when you're brewing. I'm more concerned about mashing temp than boiling temp. So, well, if you have any questions or comments, leave them for me. Please subscribe to my YouTube channel. I hope you enjoyed this video. I will try and make more. If you've got any ideas of things I should try, let me know. I got a couple. This was one of them just because I was going to be doing it anyway. I am going to make a video on line cleaning one of these days. I do have some jumpers that I use in my keezer so that I can clean all 4 lines at once with one of my pumps. It works pretty slick. So I'd like to do a video on that. Now looking over here, okay, it's boiling and my temperature says it's 209.6. So I'll bring the camera over and we'll take a quick look and then call it done. And there it is, boiling. Sorry about this, but thermometer says 210. So, thanks for watching. Take care. Okay, one final thing. After I was done checking everything, making sure the boil worked and everything was good, I decided to put a little bit of high temp RTV silicone on the inside of the element nut connection. What this is going to do is protect it from rusting. I have noticed in the past that the elements do tend to rust a little bit around where the nut is, so the RTV is going to keep the water out. Now that is 100% silicone. It's been curing for now quite a while, but once it's cured, it'll be food safe, ready to go. So that's it. Thank you for watching, and please subscribe to my channel.